Calculus is a lot about computing limits. Okay? Sometimes limits are easy to compute, but we need to be aware of what we call the indeterminate forms of a limit, okay? Which are things like 0 over 0. Okay? Why is it that 0 over 0 is indeterminate? Well, let's look at this very simple limit when x approaches 0 of x over x. Well, if you try to replace x by 0 in this expression, you would get 0 over 0, and we have some difficulties with that. But if we realize that, oh, actually x simplifies x, this is just limit when x approaches 0 of 1. Clearly 1 has nothing to do with any x, so this is just 1. Alright, but now if we look at limit when x approaches 0 of 2x over x, and if we try to do the exact same thing and replace x by 0 in here and in here, we get again 0 over 0. Now if we realize that we can simplify x, what this becomes is limit when x approaches 0 of 2, and again 2 has nothing to do with any x, so this is just 2. So what we can refer to as 0 over 0, okay, so 0 over 0, actually in one case turned out to be 1, in one case turned out to be 2, so 0 over 0 is not determined. We need to do the work in order to realize whether we can assign a certain value to what we generally call 0 over 0 when it comes to calculus. Alright? Now we can notice actually something else. So here, for example, we can write this limit, okay, limit when x approaches 0 of, instead of writing x over x, we can write limit when x approaches 0 as x times 1 over x. Alright, so now we can look at this expression when x approaches 0 as 0 times infinity. Alright, well, it depends on whether x is positive or negative. It will be 0 times plus or minus infinity, but let's refer to this as 0 times infinity. So 0 times infinity is again not determined. Okay, now how about infinity minus infinity? Let's look again at a very simple limit, okay, when we try to compute limit when x approaches infinity of x minus x. Well, if you try to kind of replace x by infinity, even though we know infinity, for now it's a symbol, okay, it's not a number, so it's kind of hard to replace it in here, but we would get infinity minus infinity. Well, what do? We don't know that yet. Probably maybe it's the first time we look at this problem, but what we realize is that in this expression we can simplify the two x's, so what we get is actually limit when x approaches infinity of 0. Well, 0 has nothing to do with any x, so this is just 0, no problem at all. Okay, now if we look at a slightly different version of this expression, so and we try to compute limit when x approaches infinity of x plus 1 minus x, again trying to somehow replace x by infinity in here, we would get infinity minus infinity. That's a problem again. But if we realize that this expression here, okay, in this expression we can simplify x, all we get is limit when x approaches infinity of 1, right? Again, 1 has nothing to do with any x, so we get in here that this limit is equal to 1. So, well, on one hand, what we can loosely refer to as infinity minus infinity, in one case turned out to be 0, in another case turned out to be 1, so we cannot associate any value to this. Okay, so infinity minus infinity has to be worked on. Okay, let's look at another situation that can cause us problems, which is something of the type 0 to the power of 0. Okay, and in order to do so, let's look at this limit when x approaches infinity of 1 over 2 to the power of x to the power of 1 over x. Again, if we try to understand what happens when x approaches infinity, to this number, well, at least intuitively, well, 2 to the power of x itself, when x approaches infinity, is going to be a huge number. 1 over a huge number is going to give us a 0, okay? If we try to sort of think of x being a huge number, 1 over x will also be very close to 0. So this is why we can refer to this as 0 to the power of 0. Now, okay, so let's see what kind of work we can do on this. So we can say this is, again, by applying some basic algebra, limit when x approaches infinity of 1 over 2 to the power of x to the power of 1 over x. Okay, and again, applying basic algebra here, this would be limit when x approaches infinity of 1 over 2. Okay, 2 to the power of x times 1 over x, right? So this is just pure 1. So this limit actually, so this expression here really does not depend on x. So it's just 1 over 2. All right. Now, if we do the exact same thing for this expression, okay, we apply the exact same algebra, we are going to get 1 over 3. So, on one hand, to something that looks like 0 to the power of 0, we were able to associate the value of 1 over 2. On the other hand, to some other expression that still looks like 0 to the power of 0, we were able to associate the value of 1 over 3. So this is why 0 to the power of 0, generally speaking, is not determined. Okay, and I'll, based off of these examples, maybe I'll let the viewers see why infinity to the power of 0 is not determined. Okay, and actually that's a very simple sort of example. If you look at this denominator here, when x approaches infinity, this is exactly something of the type infinity, which would be 2 to the power of x to the power of 0. So I'll let the viewer fill in the details and show that infinity to the power of 0 is not determined. Okay, so this would be a few basic situations when we actually have to compute limit of various expressions, and we're going to have to do some work for that. And there is one more that's actually very, very important. That's 1 to the power infinity. Okay, this is again not a determined case, but I'm going to come back to this in a future video.